Today I'm going to show you my mini project for my controller and application. It's called Comfort Monitor. What is comfort level? It's a way to describe how pleasant the surrounding environment feels based on two key factors, temperature and humidity. We humans feel the most comfortable when both of them are within a certain range. If it's either too high or too low, we may feel uncomfortable. If too hot, too cold, too dry, something like that. The next one, what is this project about? It's about smart environmental monitoring system. So it measures temperature and humidity, calculate human comfort level, display real-time data and feedback on an LCD, and detect motion using IR sensor to reduce power usage by entering sleep mode when no one is allowed. Why temperature and humidity? Because in indoor environment, it heavily depends on both temperature and humidity, which could affect mood for gut health and make you feel irritation and sticky. So why motion detection? The system uses a PIR motion sensor to detect if someone is there or not. If there is no one there, it will go to sleep mode, aka pause LCD update and sensor leads, and it will wake up when motion returns. Next one. Components. The first one here is no brainer. Arduino, you know, this one is the brain of the whole system. The second one is a DHT11 sensor. This one is for measuring the temperature and humidity. The third one here is PIR sensor for motion detection. The fourth one here is a LCD display. It shows reading and comfort level. The final one here is potentiometer for adjusting LCD contrast. This one is very important for the LCD. Look at the bottom one here. It shows you that I'm using Arduino IEE with the programming language of Arduino C++ and library of DHT.h for the DHT sensor and liquid crystal.h for controlling the LCD. So this one I will show you the circuit and code description. Here, the real look at the circuit here. So I'm not gonna go for wrong here because I got a artificial one for you to see. Here, this is the description, the circuit that you can see easier here. So there's LCD here, motion sensor, and temperature, humidity sensor, Arduino Uno, and potentiometer. Look here. This LCD has 3 ground connection, 2 power connection, and this connection connect to the potentiometer to control the contrast, and the 6 pin here connect to the pin on this Arduino Uno, and this motion sensor connect to pin 6 of the Arduino Uno, and this sensor connect to pin 7 here. Code description. I will go on to the left. Okay. These two are the library. This one an object. And here we define the sensors, pin 6 and pin 7. Here we define the LCD, there are 6 of them, the connection of the LCD to the Arduino. Here, 4 of these are the variable. I will go on detail later on. And this one is a sleep delay. We set it up at 30 seconds. Come at a setup. Here we set the PR sensor as input. We begin the LCD scan. We initialize the serial to start sending at 9600 bit per second. And here we print the starting for 2 seconds. Clear. We use the millis here to store the current time to the last motion time. The last motion time is like when the last time the motion detector detects us, the people. So until the loop, here it leaves the PIR sensor here, and here is the current millis. So it constant loop here updating. So here if the motion is high, so if the motion is detected, if it is sleeping, it will wake up here. It will report to the serial waking up. As it is clear, it's sleeping, it falls. And the last motion time will be updated by current millis. So on to the next one. Here if it is already awake, you can see the time left here. It calculated by the sleep delay minus the current millis minus last motion time. It calculates how much time left before entering sleep mode, and it use that time left. Check if it's lower than sleep delay, and then report it to the serial. It print the time until sleep here by seconds. So here to enter the sleep mode, if it is not sleeping and this here current millis minus last motion time is more than sleep delay, it will enter the sleep mode and also return to exit the loop to avoid doing anything else. So here is the current millis. Current milli is the current when it happened, and the last motion time is the last motion detected. So when these subtract together, if it is more than sleep delay, it will enter the sleep mode. So this one is nothing much. If this sleeping, it will enter sleeping, just like that. Just a redundant. So here is the CHK. Here is the lead temperature and humidity from the sensor. And if the reading is not okay here, it will show the sensor error every 2 seconds. So here, if every 5 seconds, it will toggle between the show the temperature and humidity. It will turn on true and false. And the last switch time here is the updated with the current millis. So current millis go here, and every 5 seconds we return to another display, and we will update it, go into the calculation here, loop over and over. So on to the next one. Here is how we display the temperature on and humidity on LCD. So we set the cursor, the temp. This one we need it from the sensor, and here is the character 223. Here is the little symbol here, and followed by C. And onto the humidity. Here it also lead from the humidity and also percentage. This one is the comfort level. That's why we use this one, true and false, because it's this true and false function. So it shows comfort level, and it gets comfort level from these two sensors. And the loop looping every 0.5 seconds. To the next one, it's the easy part. This method is enter sleep mode. It's nothing much really. It's just plain sleeping, and sleeping is true. So this one are the condition for comfort level. So if the temp is more than 22, less than 28, humidity is more or equal 40, and less than or equal 60, it will be comfortable. Something like this. Go on. This one is the project demonstration. This is our project demonstration. Here I'll show you how our project work, what is component and its feature. Let's start with the component. The first one is the LCD here, and the second one is the temperature and humidity sensor. This one is the motion sensor, and the fourth one is the potential meter, and the last one here, the Arduino Uno. Okay, let me plug it in. Okay, it's starting. Here you can see the on the display here the temperature and humidity, and another page is the comfort level. This one tell you the result of the sensor, how it reacts to the human body. This one is too humid for the human body because it just rained earlier. The humidity is so high, and I haven't turned on my AC yet, so it's 30 degrees here. And we have another feature. You can see the timing here. It's 20 seconds now from the 30. It starts going down. This is the sleep feature. When the motion sensor doesn't detect anyone, the number will go down slowly. So if it detects anyone, the number will turn to 30. Now let's wait for the time to sleep. Now the timer had hit 0 and it is sleeping right now. So when it's sleeping, the sensor doesn't update. Only the motion sensor does update. Let anything else just stop. That's it. Thank you so much for listening. Contribution: why is ours different? Okay, with the use of the motion sensor, our system is further optimized than any similar project. And also we got the comfort level display. Our system display both temperature, humidity, and the comfort level. If the environmental feels comfortable, too hot, too cold, too dry, too humid, it will make it easier to understand how the room feels. Our credit here. ChatGPT has helped me a lot in fixing error and guiding me to optimize this project. Okay, thanks for tuning in, for listening to my little project. Thank you so much.